Hello, everyone. I would like to present. I'm actually very glad that I'm presenting this here, because most of what I will be showing today has been built in the UK. Basically, about 95% of the additional software which we had to write on top of the open source components has been written in Cambridge. And we are quite proud with what we have built, and I hope that you will enjoy it. We call it the Quantum Virtual Broadband Network, though at the moment the parts which will be present will be mostly just how one particular node in that network functions. And what we try to build is something that will allow us to deploy new services, new applications, and and do something in broadband in a way which is different from what we do today. Today, in broadband, we have all this mess. Even if it was visible on the slide, I'll probably have to blow it up to about 4 times this screen for it to be visible. It's still not understandable to anyone. That's the reality of broadband architecture. Even the best amidst us probably know about part of it, and nobody, or very, very few people, and very exceptional people to which I'm envious, because that does require quite a lot of knowledge and qualification, know the whole thing. On top of that, from my selfish perspective as a vendor, every different service provider there has it in a different way. So anything I build for one service provider doesn't work the moment I move it to a different service provider. So it has to be customized, it has to be changed, it has to be integrated. So our idea is, what do we need to, in order, instead of having to deal with this spaghetti up there, what do we need in actually to deploy services in a streamlined manner and change things in a streamlined manner? So instead of taking 18 months to develop a new service for broadband, which is a number from a service provider in this room, I'm not going to say which one, we drop down to under 3 months for that size of service provider, or we drop under a month for the smaller ones. And the answer is not an easy answer. The answer is actually taken out of the book of the cloud guys. People like Google, people like Dropbox. It is that we virtualize and abstract a lot of this as a first step. But we virtualize both services and network, not just one or the other. And we expose this as an API, so that building a service becomes as simple as building one application. And we have built a system which does this. There are other people building systems for different, like this, for different niches in the market. We have built something that is specifically geared towards residential space. And what we are trying to do is to allow us to build services and to reduce the cost of building services, as well as to reduce the cost of running, by all means. This includes extending the life of the physical CPE, so that we don't have to change the physical CPE every time we do a new service. We can run services on the cloud platforms and scale them up and down as we need to, and allow us to test a service. Because at the moment, a large service provider, every time they test a service, face a very significant challenge, because they cannot really test on their current infrastructure. It's very difficult to say, okay, I tested on 1% of the population, the way Facebook does, and if it doesn't work, I roll it back. It doesn't quite work. So as a result, you end up with those 27-step processes where everything is verified, tested, retested, business case verified, which makes the whole service development extremely and incredibly expensive, even for a medium-sized service provider. So we have successfully built something that can actually cost in to do that in virtual space. That is quite difficult, because in order for this to cost in, you're looking at a couple of dollars or pounds, we're in the right country now, per year in terms of total cost of ownership for the infrastructure. Because, do we like it or not, at the moment the CPE has gone very, very cheap. You can buy cheap devices, so any virtual cloud solution, in order to be able to compete with them, should compete on merit, which means that it should cost somewhere there. It should also use, to the extent possible, off-the-shelf x86 software, hardware, and not be bound to particular hardware. It's all very nice and easy to say, my virtual CPE runs only on this box. Well, tough. Not everybody will buy the box, and not everybody will want to buy the box. And if it's virtual, it shouldn't be bound to hardware in the first place. It should be running on anything and should abstract it correctly. Because as long as it's bound to hardware, it's no longer virtual and shouldn't be called as such. It's a box. So what we have come up as a final result of all of our work is to this environment. I'll explain what is what on it, and we will go through the particular deployment modes and use cases in a minute. We have found a way to cost-effectively support for broadband space virtual CPE the way everybody thinks about it, and the way most vendors at the moment talk about it, where you take Ethernet and you extend it as a VLAN to the whatever is doing the virtual CPE work. However, I don't think this is the right approach, and especially it's not the right approach for migration anyway. So in addition to that, we have found out and we have managed to build a system that can support it very cost effectively. A second approach, which is not present in any virtual CPE or virtual service system at the moment, which is to use the capabilities of modern CPEs to do Ethernet over GRE or Ethernet over L2TP tunneling. That is actually present in any Linux from 3.2 onwards, and is present also in quite a lot of the non-Linux CPEs. For example, most cable modems from certain point onwards have some level of tunneling capability. So you can take a particular network attached to that CPE, and you can bridge it down to the data center. And we have successfully built a system in the data center that allows us to run legacy CPE loads or legacy Linux-based loads at very high densities. And when I'm saying high, I don't mean 200, I don't mean 400 VMs per box. I mean 2,000 now, and I mean up to 8,000 by the end of the year per box. So that you actually can reach the required cost effectiveness where you can fit your costs within a couple of dollars per that VM, the cost of running it. So for example, if I take a small PC like this one, I actually brought with myself a demo, but I'll have to break this nice audio-visual setup to show it, but on something like this, I can happily run 250. On a big box, you can run 2,000 and more onwards at the moment. And all of this has a suitably scalable orchestration. There were quite a few mentionings of Puppet earlier today. As an ex-sysadmin, I love Puppet. As a system designer, I hate it. There's no Puppet here, because Puppet simply will not scale to that size. So what we have done is we have taken internal inter-process communication that happens inside CPE software, for example, OpenWRT, or inside the Cisco OpenRG, and we have put it on an out-of-band channel, out of the VMs. First, it's secure. Second, you get half a gigabit worth of control plane rate into every VM. You no longer need to puppet it. You can tell it whatever you like at a rate which is has never been achieved on a fixed network before. Essentially, we're talking configuration changes rates that are specific only to, at the moment, to mobile network equipment. And we have done all of this on top of basic open source components. It would have been nice to write our own hypervisor. I would have loved to do that. However, we, same as some of our colleagues in the room, have found out that it's not worth it. Instead of that, we have taken two existing hypervisors and we have modified them to do what we want. And all of these modifications, by the way, will be contributed back in due course. So, as an overall result of doing this, all of these, as I said, the bill of materials to implement a successful virtual CPE system that does everything, and a virtual service system that does everything is actually quite big. We can, any of the services that used to run on these physical boxes once upon a time, oh, can I actually pick it up? Okay. Sorry. Can I get the mic? Yeah. Hello? Okay. So any of the services that used to run on these physical CPEs, or some of the services that traditionally run in the network, we can now run them in the cloud, because any one of these elements on top of the picture now sits in the home network broadcast domain. It sits at the end of a layer 2 extension, which has been designed so it is actually cost effective and can be deployed on top of nearly any network. And for example, I can run a DHCP server here. I can run a DLNA server here. I can even run a full-scale internet gateway. I can run a full-scale CPE here. And virtually no functionality to be left at the end. And depending on which network are you trying to deploy this, I can recommend you either one or the other. If we're deploying on POM or something where we actually, a very cheap gateway is a feasible proposition, we can do what everybody considers to be a virtual CPE. We can extend it as Ethernet, we can terminate it on the cloud gateway, run all the services there, control it via APIs, and do things. That is not an option for everyone. Quite a few people here have to deploy at the end of VDSL, and there are people that probably have to deploy at the end of cable. There, do you like it or not, you have to put a big CPE on the customer networks anyway. So extending you gain very, very little in terms of costs in extending that Ethernet all the way. And you actually create yourself quite a few infrastructure problems in your network. So in that case, we recommend this. As I said, every reasonably new CPE has the capability. Has it been enabled by a vendor or not? Is a different story. We essentially, in the software we ship for CPEs, we will be enabling it across the board. Will other vendors enable it? Don't know. The open source loads that are out there, like OpenWRT, all of them have it enabled already. They can tunnel. So you can take a tunnel from here, and you can terminate it on a VM in the data center. And you can do whatever you like on that VM. You can run a media server, you can run a service. It is all per customer, and you can configure it on a per customer basis out of band. You can even run a full virtual CPE. It is also one interesting, particularly interesting application for this is v6 migration and v4 sunset. We are trying to concoct all kinds of fantastic schemes to sunset v4 at the moment. I mean, when you start reading the DS Lite drafts and so on, you sometimes want to cry. The question is why? All we need to do is put the v6 gateway here on the physical, put the v4 gateway on the virtual. You have all the v4 collocated in one space. You can do whatever address mitigation strategy you like there. It's trivial, provided that you have the capability, of course. You can also do other things when we get to them. Machine to machine. I don't know, I heard a very interesting opinion with which I agree today on 6LoWPAN. I think 6LoWPAN and all the machine-to-machine protocols presently discussed in the IETF are actually not for everyone. If you look at them, the first years of implementing them in real equipment will be nightmare. So we would need gateways. And these gateways will need to be changed on a regular basis because there will be a security bug in them every 2 to 3 weeks. And when I have a security bug in my browser and so on, I update it easily. When I have a security bug in my electric meter and it shuts off the supply to my house, I'm not happy with that. So I'd actually like that to be isolated from the whole network. So if these vendors will go 6LoWPAN as they want, we would actually like to have an infrastructure where you can take the machine VLAN down somewhere handy. You can take the user VLAN somewhere down handy, and gateway between them on something which you can change, okay? And how this all works. It is no longer OSS system as at the back as we know it in most service providers. It's actually written to the same way and designed the same way as cloud systems built by cloud providers. Essentially, it is a multi-layer system with aggregation and high-performance messaging in the bottom, which is mostly based around JSON, from which point onwards it actually uses XMPP pub/sub to publish everything interesting that is happening in it. Example, once again from today. I would like to implement something as pluggable to DHCP. I can, of course, write a plugin for a DHCP server. The question is, why bother? I have my DHCP server down here on the CPE with the customer instrumented. It's producing events. It goes up, the event shows up on XMPP pub/sub. I'm subscribed to that topic. I get the event, and it is essentially a 5-line application which executes a REST call and does whatever I want with that infrastructure. For example, I can, after that, after I've gotten an event from a registered subscriber on a registered virtual CPE, I can, for example, set him his own QoS class. So, as an example, when I come home with my phone, the infrastructure will set everything for me as a simple application, me to be in a separate class, and Junior BitTorrenting music not to bother me. And it's trivial. And you can do other things. You can get location, you can get anything you want. And all of this, essentially all of our OSS plane, in all of our existing applications, examples, and so on, are organized in the same manner. You have something interesting happening in infrastructure, publish, taken via the out-of-band connection from the VM, published, up, and a simple application which is easy and debuggable, executing something in a tight control loop to do it. Probably a lot of you are wondering, okay, this is like enterprise software there. This is these numbers of VMs and so on are crazy. How does this all work? Well, I don't have a lot of time, but I'll try to go through at least some of the aspects of what we did. I'm going to skip over the demo bits because we cannot do them here. We have modified 2 hypervisors. One is UML, the other one is KVM. UML is the more interesting case because it's actually better suited for CPE applications than anything else, because it's very, very low cost and low footprint. You can run a UML VM with 12 megabytes on 32-bit hardware and with 24 megabytes on 64-bit hardware. No other hypervisor goes that low. You cannot even boot KVM before 64 megabytes. However, there's a big gap list in order to do that, which, as I said, we will be contributing to open source. We had to rewrite the whole timer system, subsystem. And anyone doing real NFV, I'm not talking NFV talking to hardware, real NFV, that's really virtual on a hypervisor, actually will have to do that too. Otherwise, it just doesn't work properly. You have to rewrite the timer system. We have also implemented new VNICs. The reason why we're able to terminate these overlays coming from the CPEs at such low cost is that we don't have virtual switching here at all for the simple use case. There's no virtual switch. The tunnel comes from the CPE. It terminates straight on the VNIC on the VM. And it's zero copy too. We have improved the memory management, and we have, most importantly, last but not least, rewritten the interrupt controller and the event loop. Because if you take a hypervisor off the shelf today, like if you take VMware, if you take KVM, you can get, let's say, 4, 8 NICs on VM. You're not going to get far building a network appliance with 4 NICs, especially if you're trying to express those NICs to map them directly onto pseudo wires to customers. What we have rewritten can actually scale to above 1024 NICs, virtual, with no penalty. And this is the bill of materials which you need if you take an off-the-shelf hypervisor to actually get that hypervisor to be able to do real virtual networking when it is working at a virtual level. It's all easy with hardware assist, but you cannot realistically get hardware assist unless it's in a very specialized box for 2,000 customers. I wouldn't even talk for 8,000. If you're trying to build something in residential space, it doesn't work. That's why we had to do that. And we're now complete with that list in the first iteration. And we're actually shipping it to trials. Basically, what I'm presenting is an existing product, which is presently being trialed in a few places. And I hope that it will reach general availability sometimes this year. I apologize for the slightly rushed presentation, but there was a very small time slot for it, so. Questions?
Okay, I think Adrian is first up.
Okay, go ahead. Yeah, we have ported all of these to Key, Linux, and so on to KVM too.
Hi.
Changes there were less.
Yeah, it's Adrian from Andrews and Arnold,
yeah.
And yeah, I'm not really sure where to start. Yeah. Maybe we've got a language barrier here. I mean, you're talking about CPE. CPE cannot, by definition, fail to be at the customer premises or be equipment. Otherwise, it's not CPE. You talk about adding services to a broadband connection. Now, we have new services. We have things like FTTC that came along, but that meant digging holes in the road and putting new cabinets in and things like that. That can't be virtualized, so I'm confused.
Service, example of a service, which, for example, a provider here in this room tried to add. Storage to the CPE. That ended up with a storage interface on the physical CPE, which was the customer had to plug a disk of their own. And instead of that, what you do is you put the storage in the cloud, and the customer sees that service. When I'm talking service, I'm not talking service as the physical layer. FTTC. I'm talking something which you put on top of it. For example, a NAS service, storage, like Dropbox, just provided by the provider.
So how is that different to Dropbox? Why wouldn't you use IP to do this? Why on earth would you? It seems very confusing.
Okay.
The other thing that I'm puzzled by is why are you using VMs for this? It sounds like you've got some sort of layer 2 tunnel from customer equipment through to something in the cloud, which, by the way, means the same as in the network. So moving from the network to the cloud doesn't make sense. But you're talking about tunneling it to a box that's doing routing and things, IP6 as a service. Why wouldn't it just be a router rather than a box that's got lots of VMs?
You can do that.
Yeah, Cisco
the
make them, I
question
think.
The question is, yes, you can do that, and this has been done. There is a problem with scaling it, which most people who have tried doing this have run into. If you tunnel the customer premises or directly expose the customer premises to a current build router, you run very quickly into limitations on the amount of state it can hold. Essentially, because it does all the lookups in high performance memory in key camps, usually. If you show it 20 max from each customer, and we are unfortunately approaching that level when you are having 20 max from each customer with all the devices we have in the home, and it will only get worse from there onwards, you very quickly exhaust the router capability to hold state long before you actually exhaust the router capability for bandwidth.
Okay, but I can't understand how making virtual machines could possibly improve that situation, because you're just splitting it down to replicating the same thing in lots of small virtual boxes. It doesn't make sense. And ultimately, things like carrier-grade NAT, which I've used the word, someone must have got bingo for CG NAT. Ultimately, things like that mean you need to hold state across multiple connections to do it. So you've got to have something that can hold session tracking at an IP session layer anyway. Are you basically saying Cisco boxes have trouble with lots of Macs, and this is your solution?
No, I'm not saying Cisco boxes. All the boxes, because actually we did not enter a single of our boxes into a virtual CPE from the box perspective tender. But customers who have tried a box-oriented virtual CPE approach All of them, we just see the requirements that are coming from them. And the first requirement is actually some of the first requirements which we see is exactly what I said on the MAC numbers, because the moment you load the full amount of MACs which that box is exposed to, it no longer is capable to be loaded to capacity.
Okay, I mean, I can't understand why you don't just have a router at the house and do services like storage, which are not a broadband service, over IP, like you do web pages and any other service that can run over IP, and you solve the problem.
Storage. There are two ways of doing storage. One is Dropbox, which is fantastic. However, Dropbox can be affordable only to a large software development organization. They have developers because they cannot expose that storage natively using the operating system storage stack. You need applications for the end devices in order to be able to access that storage. You need to have management interfaces. You cannot just show up that storage in the customer network and that storage to work as an NAS. Even if you manage to do that, you cannot after that stream directly using a consumer method to consumer equipment without, once again, helper applications. DLNA is completely out of your domain. So if a provider, for example, wants to offer a storage service that at the same time is visible to the customer using the consumer protocols such as DLNA, does the provider like it or not, that has to go into the customer broadcast and multicast domain. Otherwise, it just doesn't work.
Right, okay. I think I vaguely understand what you're saying now a little better now. You're talking about layer 2 services, essentially, that you want to extend to customer premises.
They are not. This is essentially one of the nasty things about storage. All storage nowadays operates on layer 3. Unfortunately,
we're going to have to wrap this discussion up.
Yeah. It stops working unless it is in the same layer 2 domain. This is statement of the fact. You?
Okay, quickly, because we're quite a bit behind now.
So I can see many advantages of what you're trying to do, and in all certain terms it is over IP, irrespective of where the starting point and the end point is. But the challenge I see with it is, if you have storage in the cloud, if I download it 3 or 4 times, you've paid for the CPE and bandwidth costs. You know, so if you imagine you've got a movie of your wedding day, if you watch it 4 times, you've paid for the CPE to have a disk drive in it, in terms of bandwidth costs. And if you extrapolate that out across the whole network, that kind of re-pulling down of content for things like storage services, video on demand, those sort of services, that having some local capability in the platform and in the customer's premise just pays for itself really easily.
I do not doubt. Essentially, one of the big advantages here, because you run the same legacy software in the cloud and the same legacy software, like, for example, OpenWRT or OpenRG, on the customer prem. One of the things which you can do is you can build a service in the cloud and see, without going through the same complicated process as you do today, if there is a business case or not. You can just test it and see if the customers will take it, if it will cost them. Then you do exactly as you say. If it is worth to be moved to the customer prem, you moved it to the customer prem. However, your entire process of building the service, verifying the service, and deploying the service has been vastly streamlined. It's much faster, and it's much lower cost.
That's where I kind of always kind of get on my "you're absolutely mad" bandwagon. So, what? I'm sorry, I know what you're trying to. And, you know, this is where my kind of frustration with the NFV guys really kicks in. Actually, rolling the network out isn't the hardest part. It's lead to cache, it's billing, it's taking credit cards, it's all the things that you still have to do. No matter how great you become at rolling out a service, all of the things of interacting with the human element of it is actually where most of our problems are as service providers. right? And you know, so we have a storage service in BT that you upload it to BT Cloud, and it appears as a local drive on the home hub. We've got that service. We've done it, and actually having the home hub means we can cache stuff locally, saves us a ton of money on bandwidth. So I think you need to relook at how service providers and the challenge service providers have of rolling out services, because the network component of it, in all of my experience, 9 times out of 10 is not the hard part.
Okay. Thanks for the feedback, but once again, I'm not ignoring any of that. I completely agree with you. Question is, there is also one more component. It is when you are rolling a service to 8 million customers, besides the lead to cache, you also have to multiple times justify your business case, including justifying the business case for the POC. If you're capable of running the service during that period on a bringing it up at very low cost and tearing it down at very low cost, that is the portion which is of the development which is reduced here. It does not reduce lead to cache. I'm absolutely agree with you. You still have to go through all those steps, but you no longer need to build as a first instance a service that will serve 1 million people, as an example. You can test it on 100 if you want.
Okay, right. Sorry, we need to wrap this discussion up now. Okay, thanks very much, Anton.
Yeah.